Hello everyone, this is Sai Kiran. Currently, I'm pursuing my undergraduation final year in the Department of Electronics and Communications at Rajiv Gandhi University of Knowledge and Technologies, Nujvid. And now I'm here to participate in hackathon, which was conducted by um, Global Innovations, and I'm participating in the domain of artificial intelligence. And let 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 me show the problem sets which was given by the company. And now I'm sharing the screen. Yeah, I think screen is visible to all of you. And here two problem sets they have given. The first one is illegal logging in the environment. Well, the first one is that, and the second one is we have to create a model for the efficient hand gesture recognition system. And now I'm choosing the problem set one. And no further delay, let me discuss the problem set one. Okay then. S- So let me share the screen of our model, which was created by me. Where it is? Yeah. Yeah, my system is somewhat hanging. Just wait. Yeah, it is loading. Yeah, yeah. My project is in two parts. The first one is data analysis, and the second one is comprises of data pre-processing and classification and model training. And the first and foremost thing, we have to choose the data set, right? So it is very important. So urban sound data set I have taken, and we can access by through this link. And let me show how the data set is. Okay. Okay then. So the first and foremost thing, we need to install the Librosa library, which is very useful for the classification of soundtracks. It helps for the normalization purpose, and it will normalize the data rate of the um, what it is of the music file. And for the uh, data analysis and the data representation, I'm importing the matplotlib library. And I'm also importing the Librosa library also. And these are the specifications of the Librosa data, Librosa. And coming to the, and I have taken 10 classes of data, which dogs, some kinds of serine, and some hitting and all, and such kind of things. I took 10 types of classes, and it is about 9,000 of data set, and it is about a 6 GB file. And for that, the first and foremost thing we are doing here is it is in .wav extension. And the first and foremost thing, we are here to plotting the figure, and the second one is data and sample rate. And here the sample rate is, which means per second how the data is sampled, it will tell to us. And librosa.load file name, librosa.display.waveplot data, and the sample rate, and the audio file name. So I think file name, where is the file name? Yeah. So it is the file name of dog sound So it looks like, that means the representation, the visualization of the audio of a dog of this particular file is looks like. And coming to the another sound, so which is um, yeah. So coming to the another random one I took from the urban sound 8K file. In that particular folder, we'll be having 9,000 of data sets, 9,000 of audio files we are having uh, of 10 classes. So for that purpose, we are visualizing that particular audio file also, and it looks like. And if here uh, we are printing the sample rate. The first one is 22050. So it per second, this audio is sampling is about 22.05 kilohertz. So uh, by using Librosa library. So Librosa library will give the normalized values for the sampling rate, and as well as sampling values. That means the audio file we are having, right? So it normalizes the information which is in this audio file into between the 0 and 1. This is what the use of Librosa library. Simply we can say it is helps for the normalization purpose. So here we are by using SkyPy library, we are printing the sample rate. So here sampling rate is 11025. So that is what the difference between. Okay, so by using SkyPy library, what is the information stored in the audio file is, it is in between 0 to in between some integers and float values we are getting like this. But using Librosa library will be having the information only in between the 0 and 1. This is what the main advantage of the Librosa library. And metadata, so we are reading the metadata in this particular path. So metadata is a CSV file which having um, all the audio files in that, and which those audio files are labeled. That means we are simply using the supervised machine learning algorithm here. So here we need to check whether the data is imbalanced or not. So if imbalanced means every audio file it is labeled or not. This is what we have to see. So street music is 100, and air conditioner is 100, jackhammer, engine idling. That means drilling, children playing, dog bark, siren. These are the classes. Okay, so we are using those classes, and based upon that we are classifying that. Okay, so these classes, how these classes are useful for us. Illegal logging into the environment means, for example, gunshot. So it is illegal activity. And car horn, so for the environmental purpose, we are protecting the environment. So this car horn also we need to check whether it is legal or not. Siren and children playing is normal. So for the classification purpose, we are taking some kinds of data. And drilling, that means someone is cutting the trees, so it is the illegal activity, right? So this is one of that. And the engine idling, so engine sound also, we are based upon that we are classifying whether someone has entered into the protected environment or not. So this is what about, this is the first part, that means exploratory data analysis. So that means we are analyzing the data. So for no further delay, let me open the next file, that is data pre-processing and model training also. Yeah. So Now we are in this at the stage of audio classification and as well as data pre-processing. So the first one is we have to import the Librosa library, and we'll be getting the information stored in the audio file in between the 0 to 1. This is what we call as normalization. And we are using Matplotlib, we are visualizing the audio file and the obs. So actually the information is one dimension by using Librosa, but by using SkyPy library or .wav extension we are having, right? So information is in the two-dimensional. So if we plot the .wav extension file using SkyPy library, and it is in this format, that means two-dimensional. So blue color is one dimension and yellow color is two dimension. And now we're at the stage of extracting the features. So we need one tool to extract the features. The first the tool we are using here is mel frequency capacitor coefficients. So it is a it comprises so much of mathematics. We are not ga- going in deep about the mathematics about MFCC, but it summarizes the frequency distribution across the window size, and it is possible to analyze both the frequency and time characteristics of sound. Simply, it based upon the frequency and the time constraints we are having, right, of every audio file. Based upon that, we'll be extracting some features. So based upon that, this is what the MFCC, mel frequency capacitor coefficient, will do. Okay, so MFCC, we are importing library, Librosa library, and sample rate, and all we are doing, and we are printing the shape of 40 comma 173. That means 40 rows and 173 columns, and extracting MFCC for every audio file. So it is for only one audio file, and for that we are creating for every audio file, right? So this is the metadata folder. It is a CSV dot extension file consisting all the audio files. We are just printing like that, and we are creating here what is user defined function in Python, def features a dot extract. So we need to extract every feature of every data file. So for that purpose, we are using the user defined function, and audio sample rate, and MFCC feature extraction and scale features. And for that, so we need to import numpy, because metadata is a .csv extension file. So we need to extract, we need to get those file by using numpy, numpy and pandas, right? So for that purpose, we are using we are using those libraries, and we are extracting the features by empty list, and we'll append by every iteration to the empty list. That is what. So by using pandas, we have extracted, or by using the pandas, we will create a data frame of the features and classes. So some information we got to every audio file, right? That those are the features. That is, those are independent values, but dependent values are the classes. That means whether it is sorry, whether it is street music or air conditioner sound, or jackhammer, or engine idling, or drilling, or children playing, and all such kind of classes we are having, right? So by using data frame, we'll be storing those information as features and as well as classes. So it will looks like features as a one, and corresponding class, features and corresponding to the class. And we will be extracting, we are dividing those features and classes to the x and y variables like that, and x shape. That means 8732 audio files will be having, and which comprises of 40 features. And coming to the y label, and here why is string value string where strings, right? So dog bark, children playing and all, right? So we need to label, we have to go for label encoding. So we are dumbing the variables, and which is 10 classes and which are also 8732. Okay. By using encoding, will be encoded to zeros and ones. This is what the basic behind of the label encoding. And for the model training, we are splitting our whole data into train data and test data, and uh, we are we are cutting we are storing the 80% of data for the trained purpose and 20 for the testing purpose. We are storing 80% and 20% for the training purpose. And training data looks like, and corresponding y looks like. So 00 means it is street music, and 01 means air conditioner, like that. So that was the label encoding, and those looks like. And x train dot shape, so we are it is 80% of the data only. So that why we got 6985 comma 40 and x test shape, and corresponding 1747 dot 40. uh, if we add these two, and we'll be getting the whole data set. And again, this for the y data, y also, y train and y test, and if we add those, and we'll be getting complete data set. And coming to the model creation, so using TensorFlow is has a wide range of applications in the deep learning and in the machine learning concepts, right? So we are importing the TensorFlow library, and for the here we are using only artificial neural network. So every artificial neural network will be having the denser layer, dropout layer, and activation layer, and flatten layer. So for that purpose, we are importing those layers, and we are here using Adam optimizer, and some of the metrics accuracy and all. For that purpose, we are importing the metrics also. So y dot shape, so we are number of classes here, we are storing into the num labels. And here we are creating the model creation, the sequential lot. That's like the first layer is a dense layer with 100 neurons, and the input shape is 40 comma, and up to the end of the train data. And those the input will go through the first dense layer, and that neurons output will goes to the activation function. So we are using Rayleigh activation function. And dropout layer, um, we are adding dropout layer here, and the second dense layer with 200 neurons. And again we are passing through the activation function, again dropout layer. And in the same manner, um, we are creating the third layer, and final layer is the flatten layer. Activation function is final activation function is softmax we are using. And these are the hyperparameters we can change according to our convenience and according to the accuracy we are getting. So this is the model summary, and the total parameters are 45410. And these are the trainable parameters and non-trainable parameters. These are so model dot compile, we are using loss function categorical cross entropy. Why we are using categorical cross entropy means we are having 10 types of classes. Depending upon the classes, we have to classify. So we need to minimize the error function. So for that purpose only, categorical cross entropy. This is also the hyperparameter. We can change according to our convenience. And coming to the metrics, we are using here accuracy, and optimizer is Adam optimizer. And we are classifying into 10 100 epochs, and batch size is 32. And we run the model, and we'll be getting the accuracy. How much of accuracy we'll be getting? It is about 80% of accuracy, and it is not that much of good accuracy we are getting, but it is somewhat good accuracy. Okay, so we'll be getting 80% of accuracy. Above 75% of accuracy, the model is fine, but above 90% accuracy, our model is very efficient. So training is done, right? So now we'll be doing the testing by giving some inputs. So we'll be giving a dog bark dot wave. That means we are giving dog dog sound um, to the model and how it is predicting array dot 9. So what is array dot 9? We have to see uh, array dot 9 is obviously dog bark. We'll be seeing the training data. Training is completing, right? So let's see testing also. Just wait, I will upload. Yeah. So still now we train the data and test one audio file, right? So let's see what we'll be getting. This is also same, but we have to test the some audio data. So we are giving the drilling, which is illegal activity in the protected environment, right? So the first one is we need to data pre-process by using Librosa data file. We need to normalize all the data values into 0 to 1. Information will be stored in between the 0 to 1, and as well as we need to find the MFCC coefficient for the information extraction, and we need to give that particular data into the function we have created before for the feature extractions. So these are the first one is MFCC scale features. These are the features, and these are these are all the features, and these are the shape, and this will be the shape, and this will be the uh, um, code. 4 is the label encoded value, and what is it is a drilling. We are the output, actual output is in the string format, right? So the output will be the drilling, and we given the drilling and output also drilling. So based upon that we'll be finalizing whether the illegal activity is whether the illegal activities is happening in the protected environment or not. Um, will be classified by using this model, and we can go for advanced models like CNN and all. So this is the simple try, and another note I'm giving here is we have chosen only 10 classes, right? So if we increase the class number, then we'll be having more accuracy, and our model will more efficient, and based upon the huge data we can assess whether some illegal activity is happening in the protected environment or not. So this is all about the model creation, model training, and model pre-processing and model testing. I think hope you are getting what I am explaining still now, and this is about the problem statement and solution for that. And thank you so much for accepting my presentation still now. Thank you.